So today we are going to cover chapter 4. We're going to begin it. We're going to skip over section 1, which are inverse functions. But today we're just going to talk about exponential functions. Now, earlier in the year, we actually covered how to work with exponents. So basically what we're going to do here is you're going to be given a function, and in the exponent or the power, it's going to be a variable. And then you're going to make a table of values in order to get ordered pairs to graph these exponential functions. Our first example is y is equal to 3 to the x power. Now, someone in my other class, they actually tried to key this in their calculator, and they made the mistake of just hitting the y equals button, and then they put in 3x, not 3 to the, and make this an exponent. So automatically, as soon as I saw their display and I saw it was a diagonal line, it was a linear function, I knew that they had put the x in the wrong spot. So this is 3 to the x power, not 3x. So now, if you were not using a calculator, in order to create a graph for this, we're going to do a table of values. And that's all we're doing today. So I would plug in different values of x, and then I would follow the order of operations to get the ordered pairs. So for example, remember when you plug in a negative number, and if you have a negative exponent, remember that makes it turn into a fraction. So this will actually become 1 over 3 to the second, which is 1/9. Then here, 3 to the negative 1 power becomes 1/3. Remember, anything to the 0 power equals 1. And then here, 3 to the first power is 3. And then 3 to the second power will be 9. And 3 to the third power is 27. And now I'm just going to take all of these values, or these ordered pairs now, and graph them. And then I'm going to show you what the graph of an exponential function is going to look like. Now, just like before, when we did those parent functions of the x cubed, the x squared, same thing's going to happen here. All of our exponential functions are going to take on the same shape. And then from there, we'll just adjust it. So for example, I'm going to take these ordered pairs, and it's going to be -2 to the 1/9. So I would come over here, and again, it's really close to the x-axis. So I could put it like right about there. And then if I do -1 to the 1/3, maybe a little bit higher. And then 0 and 1. And then 1 and 3. And then it goes up really fast now, and it's at 2/9. So the graph of my exponential function actually looks like this. All of the exponential functions are going to take on this shape. However, the points that are on the graph will be a little bit off. They'll be, slightly different depending on the numbers. Okay, notice this has actually got a horizontal asymptote here, which is the x-axis. Because notice how my graph is starting to skim along the x-axis there. So there is actually a horizontal asymptote here at y equals 0. Another one. Now, notice it's the same format. It's a base raised to a power. That's a variable. Again, all of my exponential functions are going to take on the same shape, but what's going to change a little bit is when we plug in the different values. Always remember, when we do our table of values, when I plug in 0, anything to the 0 power is 1. So this ordered pair is going to stay the same for all of my exponential functions. Let me put in a negative and a positive just so you can see what happens. So again, 5 to the -1 power. This means it turns into a fraction, and it's 1/5. 5 to the first power is just 5. So now if I just take these 3 points and I graph them, it's still going to take on the same shape as when I did the first one. The only difference is when it's over here at x equals 1, it's just going up a little bit faster. And then over here, and it's going down a little bit faster. But again, it's approaching that x-axis because it's an asymptote. So that would be the graph when 5 is raised to the x power. So what's changing here are these, and even when you plug in a 2. Let's try another one. Okay, now we have a fraction raised to x power. So again, we're still just doing a table of values here. So again, if I just do -1, 0, 1, and 2, if I do 1/2 to the -1 power, remember when you have a fraction raised to a negative exponent, it's like the reciprocal. So this is actually going to turn into 2 over 1. So this is 2. If I do 1/2 to the 0 power, that equals 1. 1/2 to the first power, and that's 1/2. 1/2 to the second power, this becomes 1/2 times 1/2, so this is 1/4. So now, again, it's still the same shape, but this is also going to be a reflection. So I'm going to go ahead and graph these. So -1, +2. The 0, 1 stays the same for all of these. And then 1 with the 1/2, and then 2 with the 1/4, and it's getting lower and lower. So here would be the graph of 1/2 to the x power. So for the next one, it's going to look the same as the one I just did, but I'm going to again do a table of values. So let me plug in -1, 0, and 1. When I do 2 to the negative, and then it's a negative x, so if I put -1 here, this really becomes 2 to the first power, which is 2, because the negative becomes positive. And then 2 to the -0 power is still just 1. And then 2 to the negative, and then I put the 1 there. This actually gives me the fraction. So this is going to look just like the other graph when it was 1/2. So this graph and this graph are the same. So again, if I graph my order pairs, 0 and 1, -1 and 2, and then the 1/2, and here's the graph. So again, all we're doing is practicing how to graph this without our calculator, and we do a table of values. The next one, now my base is negative. So again, table of values here. I could do -1, 0, and 1, just so I can get, represent both sides of my y-axis. So when I plug in -1, so it's -2 to the -1 power. So notice that this negative sign isn't going to be held in, so this is actually going to become -1/2. Over here, it's -2 to the 0 power. Just the 2 is being raised to the 0 power, so this gives me -1. Then -2 to the first power is just -2. So now I'll graph these order pairs. So over here, and then here, and here. And then this graph will look like this. And it's a reflection. See the negative here? It's a reflection over the x-axis. So once we learn these basic shapes, when we start to shift them, then we're just going to move it based on the shifts. And the shifts are the same that we did when they were parabolas, when they were x squared, x cubes. Same types of shifts, up and down, left and right. Next slide, I'm referring back to the very first one that I did, and it was the graph of x3 to the x power. So this is what the graph looked like. Now notice the problem that they're asking me to graph is actually y equals 3 to the x power plus 1. So this plus 1 is indicating that it's going to be a shift of 1 unit up. So if I can graph this basic one, 3 to the x power, then I would take 3 main order pairs, or whatever order pairs you have graphed, and then shift each one of them 1 unit up. So if I take my base graph, and I've got it right here, I've got the order pairs, so I'm going to graph 0, 1, 1, 3, and then I have negative 1 and then the 1/3. So about right here. So this was the base graph. I'm going to take each one of these order pairs and I'm going to shift each one 1 unit up. Yes. So for here, we're going to compare the shift and we're going to take each of these 3 order pairs and I'm going to move each one 1 unit up. So move the y-intercept up 1, this one up 1, and then also this one. And then this would be the new graph if you just base it off of the y equals 3x. So 1 unit up. The next one, this one's also a shift. Now, when it's being added or subtracted to the base, that's the shift up and down. When it's added or subtracted in the power, that's when it's the shifts left and right. And just like before, it's opposite. So it looks like it's -1 and you would think left to the negative numbers, but it's opposite. So really it's going to be a shift of 1 unit to the right. So again, if I put in the same parent here, or the same base function with the order pair 0, 1, 1, 3, and then over here the -1 and the 1/3. And then if I take each of the points and shift each one individually 1 unit to the right, this will give me my shifted graph. So then here is the correct graph of that. So just graph a base function and then from there move each order pair based on the shifts represented in the function. This one is now a negative base. Again, it's going to be like a reflection. So again, I'll do a table. And again, I'll just do a negative, the 0, and the 1. So -3 to the -1 power is actually -1/3. -3 to the 0 power is -1. And -3 to the first power is -3. And then I'll take these 3 order pairs and I will graph them. -1 and positive, or -1/3, the 0, -1, the 1, -3. And there would be your graph. And again, this negative sign is like a reflection. Now we're going to move the negative sign to the opponent. And again, let's do a table of values. Let's plug in, again, -1, 0, and 1. So 3 to the -1 power is going to give me 1/3. 3 to the 0 power is 1. 3 to the negative, actually wait, I did something wrong here. Let's check this, look at this, it's -1. Let's fix this. So this actually becomes +1. So this is 3. This one, when I plug in +1, the negative sign was part of the function. So this actually becomes the 1/3. So my graph here is going to be -1 and +3, 0 and 1, and then 1 and then the 1/3. So the graph is here. One more example. Again, we're going to take a base function of y equals -x. Notice the -1 indicates that it's a shift down 1 unit. and then the +2 would indicate it's left 2. So now let me make a table. Now if I do this one, again, my order pairs for this one were the order pairs -1, -1/3, 0, -1, and then 1, -3. So instead of having to do all of the work for this, I can just take these and shift each one down and 2 to the left. So let me graph these 3 here, and 1, 2, 3, and then here. So this would be the base function. And now I'm going to take each one of these blue points and I'm going to move them 1 down, 2 to the left. So 1 down, 2 to the left, 1 down, 2 to the left, 1 down, 2 to the left. So here would be the new graph. So just graph a base and then from there apply the shifts. That's going to be the easiest way when you're given an exponential function that looks like this. So Friday, we will learn how to solve exponential functions. So I will give you a homework assignment on Friday and it'll be due on Monday. So what you should be doing now for the next 2 days is, again, practicing with your calculator, looking over the test review, and any past homework or notes. The test covers 3.1 to 3.5.